This is Mr. Beck Does Your Homework. This is AP Physics, homework number 6.3, question number 6. A 5.22 gram bullet, so watch out for that, is fired into a 3.73 kilogram ballistic pendulum and becomes embedded in it. The acceleration of gravity is, if the pendulum rises a vertical distance of 5.15 centimeters, calculate the initial speed of the bullet. So I have a bullet flying along. It's going to slam into this block. This block is suspended somehow. When it slams into the block is going to move up. And so these strings are going to be this way, and it's going to have the bullet inside of it when it moves up. And it's going to move some height, and that they give me. So a ballistic pendulum allows this allows this bullet's momentum to slam into the block so that you've got a conservation of momentum between the bullet and the block. Then it's got an initial velocity, and then it's got some kinetic energy with that velocity. That kinetic energy is conserved as it's converted into potential energy up here. So I've got a two-part problem. I've got a momentum is conserved between the bullet and the block, and then I've got an energy is conserved after the bullet is embedded in the block. So since they give me the distance here and the masses of the bullet and the block, I can figure out my conservation of energy part first. So let me do my energy is conserved over here. The energy that is conserved is that the Ke immediately after the collision is going to equal the Pe when it comes to rest up here. So my Ke is going to be 1/2 mv squared equals my Pe up top, which is mgh. Well, my mass cancels out in this part of it, so the velocity of the bullet, the velocity of the block and bullet is going to be the square root of twice the acceleration of gravity times the height. So my velocity is going to be the square root of twice 9.8, and the height they give me is 5.15 centimeters, and I know that that's 0.0515, so that you convert properly into meters. That'll give me the velocity of the bullet after it has been embedded in the block. That's the velocity of the bullet and block. Now I've got myself a momentum problem. So this is a momentum problem, the bullet hitting the block. So now I've got a momentum is conserved for the other part of it. For my momentum is conserved, beforehand I've got a bullet moving at some velocity and a block standing still. Afterwards, I've got a bullet in a block moving at some velocity. Oh, there's the velocity that's moving at. So this velocity is this velocity here. So here's the mass of the bullet, mass of the block. Well, that's 0.522 grams, and that's 3.73 kilograms. So this is going to be 0.00522 plus my 3.73. So that's 5.22 grams converted into kilograms, 3 decimal places. That times my velocity from down here is going to equal the mass of the bullet, 0.00522, times the bullet's initial velocity. So I can solve for my initial velocity of the bullet using that conservation of momentum.